Welcome back, everyone, to another day of Azure Data Engineering. And if you remember, yesterday we were talking about cloud computing. We had seen the basics of cloud computing as to what it is, what it means, right? And how it is made. Now, we saw the three cloud models, right? That was the private, public, and hybrid cloud. And we'll continue from there today, and we'll try to understand the different cloud services which are there, right? Now you are aware of these different cloud services. Uh, you commonly call them infrastructure as a service. You would have heard of it, right? You would have heard of platform as a service. So let's break down what is infrastructure as a service, what is platform as a service, what is software as a service in a very easy to understand way, right? And we'll focus on the responsibilities of two people, right? So when you talk about cloud services, what we need to understand is the difference between the responsibilities, right? And these responsibilities, they belong to either Microsoft or the user who's working with the cloud, right? So it's either you or it is Microsoft. So this is what the responsibility sharing, how you define it, basically defines what type of cloud service are you using, right? So you will try to understand, or we will try to understand here the responsibilities and the control over the different layers of the technology stack that exist, right? So we'll start with the first one, which is infrastructure as a service, IaaS as you call it, right? Commonly. Now, infrastructure as a service, it provides a virtualized computing resource over the internet, right? So you will have here a proper computing resource provided to you over the internet, right? It's like renting the building block of an IT infrastructure, right? For example, servers, you will get servers here, you will get storage, yes, you'll get networking also. So everything you get. Now, when we start talking about public cloud, right? The moment you start talking about public cloud, let's break it down, right? So this means that we are talking about either Azure or AWS or GCP. Now, one more thing that public cloud tells us is that the data center will be managed by these CSPs. They will have their data center in place, right? So this means the data center belongs to the CSP, correct? Now, what level of control the CSP is giving to you will define the different cloud services that we have. Now, to a certain degree, the control will always remain with the cloud service provider, right? For example, the hardware control. Who will have the control over the hardware? Now, since this hardware is present in a data center that is owned by the CSP, which is either your Azure or AWS or GCP, that means that the hardware will be managed by the CSP itself, right? I am not allowed to go inside the data center and I'm not allowed to touch the hardware or look at the hardware. That is not allowed. If I need to access it, I have to do it over the internet, right? So what comes under the hardware? Your servers, right? Storage, networking services or equipments, right? So all of this will be managed by the cloud service provider. The first thing is that the uh, server, storage, networking, hardware will be managed by them. The other thing that the cloud service provider will manage is the data center itself. The data center building will be managed by them. Yes. And Microsoft here, so if we take the example of Azure, right? So Microsoft here will also make sure that this data center is secure. It has power supply, it has internet supply, it has the cooling mechanism working, right? Because these data centers, they generate a huge amount of heat, right? These servers, they generate a lot of heat. And that is why we need a proper cooling system in these data centers. So all of this will be made sure by Microsoft. That is what Microsoft will manage. All right. Now, the moment you talk about hardware, right? We say that the hardware will be managed by Microsoft, correct? What comes on top of the hardware is the operating system. All right. The Microsoft here itself will provide you with the virtualization layer or the hypervisor to create this virtual machine that you're going to create. Now we'll talk about virtual machine later, but essentially what I want you to understand is when you have the hardware in place, now next thing that you need is the operating system. Inside the operating system, you will have applications. Yes, using those applications, you will do the development work and you will require some data also, right? Correct? So you have data, you have the development environment, you have the applications that you install, and you have the operating system. All of these, all of them will be managed by the user and not Microsoft. So the moment I start talking about infrastructure as a service, that is the moment where I tell them that Microsoft manages a certain thing mandatorily. All right. So hardware is a mandatory management layer for Microsoft. So Microsoft has to manage the hardware and whatever lies below, right? But whatever comes on top of the hardware, if you are getting access to manage all of that, you are talking about infrastructure as a service. That means I have given you the entire infrastructure. All right. You can install and manage the operating system on these virtual machines. You can manage the application data, the middleware, right? The patching, updating, securing of the operating system, everything you have to do on your own, right? So imagine that you're renting a bare apartment, right? So when I say it's a bare apartment, where you have to settle down and you have the control over everything. When I say control over everything, so in a bare apartment, you get to decide what wall paint you want, you get to decide what furniture you want, you get to decide which room are you going to stay in, right? Which room is going to be a bedroom, which room is going to be a study room, which how you want your kitchen to be built. So it's like the maximum control that you can have is in infrastructure as a service. All right. So the maximum control that you can get in a cloud environment is your infrastructure as a service, where you get to control the operating system, you get to control all the applications, you get to control the development environment, you get to develop applications there, writing code, yes, and you also deal with the data. So everything is in your hands in a infrastructure as a service offering. So now Microsoft has given you a building, right? An empty building with electricity, water, and security. Yes, but you are responsible for furnishing the entire apartment, right? Decorating it, maintaining it. All of it is your headache. Is that clear? So one of the most common example of infrastructure as a service is something that we call as a virtual machine. Now you may have heard of a virtual machine. Yes, it's like creating a machine on the cloud, right? A physical machine that you have, or your laptop, right? Or a physical machine that you have. Creating that on the cloud is infrastructure as a service. Why? Because when you create a VM, you get to decide what operating system this VM will run on, right? I have the freedom to decide whether it's going to be a Windows machine or a Linux based machine, right? Or even if it's a Windows based machine, which version of Windows? It's Windows 10, 11, data center edition, whatever you want, right? Pro, home, whatever it is. Then I also get to install any application within that VM. I get to write my code within that VM. I get to store my data and deal with that data also inside a VM. So therefore, whenever in life you get a question on infrastructure as service, think of a virtual machine. The best possible example, whatever you can do with a virtual machine, you can do within infrastructure as a service. Is that clear to everybody? Yes. Now,
Yes.
so that is infrastructure as a service for you, where we say, one second. Yeah. So where we say the servers and the storage will be managed by Microsoft. The networking within the data center will be managed by Microsoft. The data center building itself, everything will be managed by Microsoft. Whatever you build on top of it is a part of infrastructure as a service, right? So above this layer, the hardware layer, I would say, right? Microsoft has given you the complete control. All right. So virtual machines, virtual desktops, they're all example of infrastructure as a service. Now we come to platform as a service offering, right? Now, platform as a service offering, it provides you with a platform, right? And this platform is for developers, right? So developers can build, right? Deploy, manage. They can do all of this about with their application without worrying about the underlying infrastructure or the hardware. All right. So now think of this as getting a fully furnished house, right? Uh, Previously, we decided that an empty building is something which is like, uh, let's say, your infrastructure as a service. So think of platform as a service as a fully equipped kitchen. Everything is present here. This kitchen is for you. All you have to do is come here, cook your meal, and then consume it and leave. That is all. So now Microsoft not only manages the server, storage, networking, data center, it also manages the operating systems. It also manages all the runtime environments. It also manages the development tools, right? So basically what you do here is you inform Microsoft that you want to develop, let's say, a Python-based application, and Microsoft is going to give you an environment or a platform where you can do that, where you can develop that application, where you can host that application, where you can test that application, right? So here scaling, load balancing, security patches for the platform, it is all Microsoft's responsibility. All right. Your responsibility as a user is only to develop and deploy those applications. All right. Or to manage the application data and the configurations of your application. All right. I do not have to worry about the operating system, the runtime, or the infrastructure. All right. So as I said, think of platform as a service as renting a fully equipped kitchen, right? Where Microsoft's responsibility would be to manage the appliances, the plumbing in the kitchen, the electricity, the raw materials, right? And what the user has to do is just come there using the raw materials, cook its own meal, right? That is to write the application code, and then you cook the meal, you develop and deploy the applications without worrying about anything about the kitchen. You don't have to worry about maintaining the kitchen. So that is platform as a service for you. So I'm giving you a platform, I'm giving you an environment where you can go ahead and develop your applications, right? So for example, in Azure, we have a very important service known as Azure App Service. Now, Azure App Service is a service within Azure that allows you to host web applications. All right. So if I've developed a web application, I can, host it using app service. App service will give me, or Microsoft through app service will give me the servers. It'll manage the operating system also. The server is given by the by Microsoft. That means that CPU and the RAM usage will also be given by Microsoft. While as a developer, my focus will only be to write the code in deploying and developing the applications. That is all my headache, right? I don't have to worry about anything else. So that is platform as a service for you, right? Where most of the control is taken away from you. Then we have the third thing, which is your software as a service. Now, software as a service, in very simple terms, right? It gives you or it delivers you a fully functional application. So what you get here is a fully functional application, right? You get this over the internet. All right. So it's like ordering food from a restaurant. Everything is ready. Everything is developed by somebody else, managed by somebody else. They will just give it to you, and all you have to do it, eat it, consume it. And that is software as a service for you. These are those applications that are developed by a third party, delivered to you over the internet, right? So when you talk about software as a service, here Microsoft will manage everything: the infrastructure, the operating system, uh, the networking, the data center building, the runtime, the middlewares, application, and all you have to provide is your data. That is it. You don't have to worry about anything. All right. So let's think of an example where you have seen platform as a service of sorry, software as a service offerings, right? So these are ready to use applications. So based on a particular requirement that I may have, yes. For example, if I want to send a mail, I have ready to use applications available. What are they? Gmail, Outlook. If I want to store data, sorry, if I want to store data, then I have Google Drive and I have OneDrive from Microsoft. All right. If my objective is to have a meeting with all of you, then I have Google Meet and Microsoft Teams. So this is just an example, right? These are ready to use softwares, ready to use applications that are helping the user. And all I'm doing is I'm consuming these services. And what do I provide to these services? What do I give here, right? Or what level of control do I have? For example, when you talk about infrastructure as a service, you said that you have control over operating system, you have control over applications, you have control over development and code, and you had control over data, right? Then you come to platform as a service offering and you say operating system and application is taken away. All I have to do is development and code and deal with the data. The moment you come to software as a service offering, all you have now left is data. Clear? All you can provide now is data. For example, if I want to send a mail, whatever my mail body is, whatever I'm sending in the mail is my data, right? If I want to store some data, right? I open Google Drive and what do I provide put in the inside Google Drive? I put my data there, right? If I want to have a meeting, whatever I say in the meeting is the data that I'm sharing, right? So here my only control is over the data. Now, one thing that you have to understand is that cloud benefits, right? So there is a simple term called cloud benefits. And there are a lot of cloud benefits. There are cloud benefits such as scaling, fault tolerance, availability. All of these cloud benefits are taken care by, or they're taken care by Microsoft. Microsoft takes care of all of these cloud benefits when it is platform as a service and software as a service. Most of the cloud benefits are taken care of by Microsoft in platform as a service offerings and software as a service offerings. For example, availability, or let's use a simple term called scaling. If, for example, Gmail is not accessible, right? And the reason behind this is, let's say there is a sudden surge of number of users trying to access Gmail, which has put a lot of load on the servers where this is hosted, right? So obviously it becomes inaccessible to a certain set of users. Now my question is, do you ever get to go and tell Google that your application is not working? Does it happen? Has it ever happened that your application is not working properly? Maybe you want to scale it up, right? I'm facing access issues. Looks like a lot of people are using it. No, you don't have to do it. That will be taken care of by the service provider itself. So Google in this case will take care of scaling. Google will take care of backup, right? You don't have to back up your mail data. Yes or no? Google will make sure that it is always available to the users. For example, I don't know how many of you know. What do you think? Whatever data you put on Google Drive, how many copies do you think is created of this data? Does anybody has any idea? How many copies do you think are created of your data?
3, maybe.
Multiple copies, right? Generally three. So the reason behind that is Google knows that if it is going to store the data in one of the storage services, right? Let's say in one storage container they've stored it, there is a chance that that storage container may get damaged, right? Due to a lot of reasons. There could be a disaster, there could be some problem with the data center itself, right? So multiple reasons are possible for this data to be lost, right? Or to data to be deleted or to become inaccessible. Has Google Drive ever come to anybody and told that, your data, sorry, we've lost it? One of our devices where your data was kept is not functioning anymore. So we are extremely sorry, but we can't give your data back. That never happens, right? Because that is something for which Google has already prepared for. And that is something called as a fault tolerance, right? So how fault tolerant systems can you make? Then in that case, if you want to make or if you want to make sure that the data that you have stored is, it does not get deleted accidentally, or due to some disaster or some accident it is not deleted, or the, let's say, the storage container itself getting damaged. That is why Google will store at least three copies of your data, right? And when it comes to cloud computing, three is some sort of a magic number, right? You will always find three very commonly there, right? Whenever you're talking about redundancies, copies, in those cases, three is the go-to number, right? We'll also discuss about this when you talk about the storage account. So Google stores this data in multiple locations so that in later date or in a later day, if for some reason the storage service gets damaged, then I don't have to go to the user and tell them, listen, we have lost your data. That is never going to happen. Your data will always be there. Google will always make sure that your data is present. So these are some of the benefits that you get with platform as a service offering and software as a service offerings. Similarly, in platform as a service offering, since Microsoft is taking care of the platform, since the platform itself will be taken care of by Microsoft, where you are going to go and develop your application. Therefore, the Microsoft will make sure that this platform is always accessible. This platform never goes down. This platform, there is no problem with this platform. So entire management, most of the cloud benefits will be taken care of by Microsoft itself in this particular case. All right. So these are your multiple cloud services. If you want to remember them in a very short format, just remember infrastructure as a service basically means complete control. All right. Here you will always do development. All right. And in software as a service, you will always consume the service. You don't have to do anything. Clear? All right then. So next, we'll talk about some of the cloud benefits, right? Uh, Now, there are multiple cloud benefits, right? And here we are going to talk about a few, and these are one of the most uh, common and the famous cloud benefits that you'll see everywhere, right? Starting from high availability, right? Now, we'll try to understand what high availability basically means. We'll try to understand what scalability means, right? So we'll go like 1, 2, 3, 4, 5, 6, 7, and sorry, 8, right? So we'll try to discuss all of these 8 different cloud benefits that we have. Now, talking about the first one, high availability. Now, the term availability basically means that the application if we are talking about a cloud-based application, VM, if you've created a virtual machine, or any cloud service. For example, you've created, let's say, a Databricks environment, right? You've created a Databricks workspace. So that Databricks workspace should always be available to you. Similarly, if you've created a data factory workspace, that workspace should always be available to you. You should be able to access it. That is availability. All right. So high availability means that the application or a virtual machine or any cloud service I've created is always accessible. Always accessible. All right. Now you may have noticed in some scenarios, for example, let's take the example of State Bank of India, right? So most of the banks, the government banks, whenever you go there, right, for any work, any task, you go there, they generally tell you that the servers are down, right? So generally, this is their go-to response to everybody that the servers are down, right? I'm not sure if it happens today, but back in the day, this was a very common scenario. Now, when somebody says that the servers are down, that means their banking application is not available for them, right? They're not able to access the banking applications, right? Now, if they're not able to access the banking application, that creates a lot of problems for the users. Yes, it creates a really bad experience for the users. Correct? Now, low availability or no availability has a lot of negatives, right? It may create a very serious problem sometime, right? Sometimes I've also seen in some of the hospitals, right, big government hospitals, they generally stop their operations. They're like, the servers are down, we can't do anything, right? And similarly with the banking applications, the servers are down, we cannot do anything. Or sometimes, how many of you've tried to book train tickets from IRCTC, especially the Tatkal tickets? Has anyone tried? How's the experience
It was
for
very
those of
bad.
you?
I have been like booking for probably since 2000. 12 or maybe way before. It used to be, I don't know currently what's happening there. I'm sure same status, I guess. It used to be very difficult, especially that morning time when it opens.
Yes. So you try to, anybody who has not booked a train ticket before, try to open IRCTC at 10 a.m. every day. You'll understand what the actual pain it is, right?
Yeah,
So
uh, it was very bad. This SBI bank always their ATMs are out.
yeah, so this is what low availability means,
Yeah,
right?
and
So
recently
this
I
is
heard TCS took over SBI Bank and it started getting better like few
maybe
years
I'm
back.
not sure. I'm not a customer anymore, right? I
Okay.
switched while I had time. So So when you talk about these scenarios, right, all of you can understand how negative the image for those banks become, how negative the image of the brand becomes. Why? Just because of this low availability of their services, right? Even IRCTC, people find it really hard to book train tickets in the morning at 10 a.m. when they open up the Tatkal bookings. Now, these are all examples of low availability. That means that the application is not accessible by the users, right? These are real life examples. And why would anybody come to a cloud service provider, right? Because see, IRCTC or SBI, back in the day, all of them, they had their own data centers, right? Banking companies generally have their own data centers, right? They don't rely on cloud service providers because they think that their data is really important, it's secret, right? And they don't want to put it over the internet or want to access it over the internet. So most of the banking organizations or your defense or these top secret organizations who are working on top secret projects, they generally don't tend to use cloud services or public cloud services, right? That is the reason why they don't want is the reason why they don't want it is because they don't want to host their data which is accessible over the internet. They don't want to do that. So generally, they maintain a private cloud. Similarly, for IRCTC also, they will have their own data centers, they will have their own service. Now, how can Azure come into the market? Yes, if Azure comes to the market or AWS comes to the market, how can they convince these organizations then, come to us and we'll sort out this problem of low availability. All
I
right, we'll
heard
make
it
sure.
is based on scalability, like based on the demand of request.
Absolutely.
It's
Yes,
yeah.
absolutely. It depends on the traffic. It depends on a lot of things actually, right? How you have configured it, how many copies of your services are running, right? If you just have a single copy of your service running on one server, what if that server gets damaged? Your application has gone down, right? So we'll take a look at a lot of different availability options, even when it comes to different, services on Azure. Now, what happens here is when Azure comes to them, right? Or if I am an organization, why should I go to Azure and not build my own data center, right? The answer is really simple. My own data center will have a lot of challenges, right? Scalability being one of them. In a personal data center, sometimes I may not be able to scale beyond a particular point, beyond a certain point, but that is not true about these public cloud service providers, right? They offer you very high scalability and they offer you very robust scalability mechanisms also. There is manual scaling available, there is auto scaling available based on certain conditions, right? Based on certain metrics, you can enable auto scaling as well here. So cloud companies, they came into the picture and they said, I am going to give you high availability. And I'm not just going to give you high availability, I am going to give an SLA for this availability. Now, what is an SLA? An SLA stands for service level agreement. All right. Now, the service level agreement is like a guarantee. So now we have a cloud service provider giving guarantee or giving an SLA. And these SLA, they are like 99%. There are 99.90% SLA also. Uh, right? There is 99.95% SLA also in some cases. There is 99.99% SLA also in some cases. So what are these different SLA values? This means if I'm selecting something which has an SLA of 99.90, that means that in a single month, right? That is 30 days. In a single month, your application, your virtual machine, or any other cloud service that you're using, that service will be available for 99.90% of the time. That is a guarantee that we are giving you. Your application will not go down. It will always be accessible. All right. And this is a guarantee. So if it goes below this, right? If the service has been down for more than this duration, right? That is 0.10% of the time. You can calculate 30 days into 24 hours into, uh, you know, whatever the duration in minutes will come. You can calculate the 0.1% of it and it will come to around, I think, whatever it is, 40 minutes or 20 minutes or 1 minute, 4 minutes, something like that it will come. So whatever it is, Azure is giving you a guarantee that the application will not go down for more than that time duration. All right. So now you have a guarantee, a promise from the cloud service provider. It will not go down. If it goes down, they will return you the money that they have charged for the entire month. You don't have to pay anything for the entire month. So that is why these cloud companies are becoming really popular because they provide really high availability. They give you really high availability, all right, with various services, and they have a lot of mechanisms in place that they implement. And one of the most, I would say, common way of increasing the availability is through redundancy. Redundancy means creating copies, right? So if I'm saying a service is redundant, I'm saying multiple instances of that service will run, right? In certain cases of a virtual machine, right? What Azure will do is will create multiple copies of the virtual machine. Now, if this particular virtual machine has gone down, you will have two other running. And these are arranged in different ways. When we talk about virtual machines, then we'll see you have availability set that you can create, you have availability zone that you can create, right? The different or virtual machine scale set is also an option of scaling your virtual machines. Now, that is availability for you. And we ended that discussion with scaling our virtual machine. So let's try to see what scalability means. Now, scalability in very simple terms means to increase the capacity of your resource. All right. You have two types of scalabilities. One is horizontal scaling. The second is vertical scaling. Scalability, in very simple terms, as I said, it refers to the ability of a system or an application or any service running on Azure to handle its growth, all right, to increase with demand, all right, and it does so without compromising the performance. If there is high demand, then I have to increase in size. I have to handle the growth. I have to handle the growth in traffic, the number of users. If they increase on the application and the application is becoming, or let's say the servers are, getting overloaded, in that case, I should be able to scale that up. I should be able to increase the number of servers, or let's say increase the capacity, anything. All right. So you have two terms here. You have scale up, which is like handle more, right? If you want to handle more, then you scale up. And if you want to handle less, you scale down. All right. So think of scalability as a rubber band, right? So you have a rubber band in hand, or let's say a piece of rubber like this, and you are stretching it. If there is increase in demand, you stretch it. All right. If there is increase in demand, it should expand. When you are stretching it, it should expand. And this expansion should happen without breaking. Easily, it should be able to expand when you stretch it, when you increase the demand. And when the de demand decreases, right? Then you should, if you let it go, it should return to its original size. All right. And as I said, there are two types of scalability. One is horizontal scaling and one is vertical scaling. So let's try to understand both of them. Now, we'll first talk about horizontal scaling, right? Now, back in the day, when you talk about big data processing, now those of you who are not aware of what big data processing means, just think big data means huge amount of data. All right. You can imagine big data to be huge amounts of data. So for example, you have a pinch of sand in your hand, right? That is a normal data. If I ask you that I'm giving you a pinch of sand and you have to count number of particles there, all right, you may be able to do it. Someone over here, or most of us here, if we spend some time with concentration, we may be able to count the number of particles available in that pinch of sand. But if I give you an entire beach, will you be able to count? Will you be able to count? The answer is no.
No.
This is big data. Data which is impossible to handle by, your normal systems. All right. So when earlier back in the day, we were processing big data, that means we were handling this huge amounts of data and trying to, process that data, clean that data, format that data. We were using, the first thing that we used was a monolithic system. This monolithic system was a single machine, but this was a single very large machine. All right. We kept on increasing the size of this single machine up until a point where it became impossible to add more resources, right? You have huge amounts of CPU, RAM, and storage present here. Yes, but this was a single machine. There was a limit to which you can scale this machine up. This is called as your vertical scaling. This is my vertical scaling, where I increase the capacity of an existing system. All right, that is my horizontal scaling. Then, if you remember, how many of you worked with Hadoop or you know what Hadoop is? Anybody here? Yes or no? Anybody heard of it, knows what it is, knows about
See,
distributed computing?
I worked a bit in a project, but that like as a user, my from my side, there was no
Mm-hmm.
much difference because we had an accelerating layer on top of it called Review, where it was like
Okay.
just SQL queries we were firing up. So it was looking like just like a relational database. It's just we have to load every time all the data as at that time as this incremental load was not
There.
happening.
Hmm. Yeah.
So
All right. So you have some understanding of Hadoop. You know that Hadoop uses something called as distributed computing.
yeah, I have heard all of this, but still there is like no point. Everything is clearly explained that made it clean and transparent regarding Hadoop, Spark, and things.
All right. So now, back in the day, we were using these monolithic systems, as we have already discussed, that you had a single machine and you kept on increasing the size of this single machine up until a point where you reached a maximum limit, right? So what you were doing, you were scaling this machine vertically every time, right? So you was increasing the capacity of the existing machine every time. And this became an example of vertical scaling. But this method was not useful. All right. This method had its limitations. As I said, there was a limit up to which you could scale the resources. And then this was not a fault tolerant system. All right. Any fault that occurred, it's a single machine. Any fault that occurs, the entire machine goes down, your entire data and processing is done for the day. All right. So over here, you were relying on a single machine. You were trying to scale it up vertically. It was difficult to manage it, right? And that is where Hadoop came into the picture, right? And Hadoop distributed, you basically defined two things. One was the distributed computing and the distributed storage, and obviously the MapReduce function that it uses to process the data. So we're not going to go into the MapReduce function as of now. We'll discuss about it when we talk about Spark. There we'll see how Hadoop started and what were the limitations with Hadoop and why we went to the Spark architecture. Now, this distributed computing is a phenomena where instead of processing your data on a single machine, you create a cluster. You create a cluster of smaller machines, right? So if you had a large chunk of data here to process on this single machine, now what you will do, you will break this data down into smaller pieces, right? Let's say this is part one of the data, part two, part three, part four, part five. So part 1 of the data will come here, part 2 of the data will come here, part 3 of the data will come here, part 4 will come here, part 5 will come here, and all of this data will be processed in parallel. There will be a master here which will manage the entire execution, right? So you don't have to worry about this. But what I'm trying to say is, as the data increased, if the data increases, I will add more nodes. So this is my cluster. These machines are called as nodes. These are nodes of my cluster, right? So when the data increased, when the workload increased, I could easily go and add more nodes to this cluster for the increased processing power that I needed. All right. And this is something which is called as horizontal scaling, right? So I am increasing the number of machines horizontally. I'm not increasing the capacity of an existing machine. I'm increasing the capacity horizontally, right? I'm adding more machines. Does that make sense?
Yes.
Yes. Now what happens in this case, I have no limitations as such, right? This master node, which is also called as the driver node, which you will see when we talk about you know Hadoop systems and the distributed computing system later on in the course, there you will see that this driver node, with help of a cluster manager, right? So there is a cluster manager. For example, in Hadoop we had Yarn, you have Kubernetes, right, which is also a cluster manager. So this cluster manager will manage all of these single nodes, right, with the help of the master node. Whatever master node gives to process, the cluster manager will distribute it. If any of the machine is empty, the cluster manager will inform the master that I have a single machine available, please give me the data, right? So like this, the data is divided and then processed on these multiple nodes or multiple machines. That is the concept of distributed computing. So rather than processing all of the data on a single machine, what I am doing is I have created number of machines and I'm distributing my workload on these multiple machines where all of my data will be processed in parallel. These systems are also fault tolerant because if any of the node has gone down, the cluster manager will inform the driver. They will know what data they had sent. They can get rid of this node. They can send this data again to another, let's say, machine whenever it is made available. And this fourth part of the data will be then processed again. And in the end, whatever data is processed in order, it is all combined together in the output, and you get the output data, which is nothing but the processed data combined coming from different machines. So I did not want it to, introduce you to distributed computing as of now, but what horizontal scaling is one of the most classical. The example that you can use to explain horizontal scaling is the distributed computing example, right? Where we keep on adding more machines as and when the workload increases. So that is, scaling for you. You increase the capacity of an existing machine, or you add more resources. Then you have this particular global reach. Now, this again is a very important cloud benefit, and there are multiple reasons for it. Why is global reach important? And when I say global reach, what I'm trying to explain is that Azure, or in your case, in some other cloud's case, it could be AWS or GCP or any other cloud service provider. These service providers are available across the world. They're available across the globe. They're present everywhere. The data centers, Azure's data center is available everywhere, right? Azure will have a data center in every region, right? In fact, uh, in the next section, I will tell you what is the relation between a region, a data center, right? What is a zone, all of these things. But before that, right, what I want to explain you is the power of global reach, as to why this global reach is important. Now, Azure is present across the globe, right? And I can explain it to you with an example that in India itself, Azure has three regions. Region one is India South. Region two is India West. And region three is India. Does anybody know where these data centers or these regions are available? So see, I will just quickly explain to you, or maybe some of you are getting confused. A region is like a physical geographical location where we have data centers present. All right. A region could be made up of one data center or multiple. Generally, three, three data centers. All right. So a region is like the superset of a data center. This is India South region. Here I will have data centers. This is India West region. Here I will have data centers, right? So India South is in your Chennai. Those of you who know already, those of you who do not know, it is present in Chennai. West is Mumbai and central is Pune, right? So Azure has three regions in India: Chennai, Mumbai, and Pune. And here Azure will have one or more data centers in these regions. Clear? That is clear, right? Data center is called as a zone in Azure. When you talk about Azure, when you talk about in terms of the terminology that Azure uses, data centers are called as zones. So I can say a region is where I will find either one zone or multiple zones, right? Zone here means data centers. So I have so many data regions present in India. Similarly, I have so many regions across Europe. I have regions in America. Yes, I have regions available in Korea, South Korea, Japan, Australia. There are a couple of regions in South Africa. You have regions present. You don't have a lot of regions present in locations where they don't have a huge IT infrastructure available. For example, South American countries, you will barely find a data center there. I think there is one in Brazil. And similarly for African countries, they don't have a lot of data centers there or a lot of regions there, right? You will generally find only two regions available there, which are in your South Africa country. Now, apart from that, wherever there is a huge IT infrastructure, Azure will have its region present there. A lot of regions in US, a lot of regions in Canada, in Europe, across Europe, in Middle East, right? You'll find a few regions in China also, but we'll talk about China separately because it's a separate case altogether. Then you have regions in India, Australia, Japan, right? South Korea, a lot of places. Now, what is the need? Why does Azure have to be present across these regions? What is the actual need? The answer basically lies in two important points. Can you tell me what do you think? Why do we have so many regions available across the world? Why can't I be sitting in India, access a region in US, or create my resources somewhere in US, or store my data in US? All right, so I've answered both the points now.
Due to some legal compliances also,
Absolutely
we
correct. Absolutely correct. One is latency. Yes, Azure wants to cater to the high demand or cloud computing demand coming from a lot of countries. And to cater to those demands and to offer these services with lowest latency, right? It is creating these data centers across the globe. The second reason, uh, as somebody very nicely pointed out, is the legal compliance, legal and compliance related issues. Now, what legal and compliance related issues are there? How many of you had American Express card? Anyone here using Amex card or MasterCard? We have, right? A lot of people will be using Amex and a MasterCard. In 2021, both of these companies were banned from issuing any new cards. All right, the existing ones would work, but they were banned from issuing new cards. Does anybody know? Did you face this issue around that time? Did you try to get a MasterCard or an Amex card around 2021? So around 2020 or 2021, right? I'm not sure of the timeline, but around that time, this happened. Now, why did Government of India ban these two organizations from issuing cards in India? All right. So what happened was the Government of India came out with a new policy around that time, right? You remember a lot of outrage was going on with all these Chinese apps around that time during the COVID time. And then India had a new IT policy as well. So there the government regulated all companies, all right, whether Indian or companies from abroad, serving Indian customers. They were asked to store all sensitive information of Indian citizens in India. That data should not go outside India. That is what the Indian government instructed them, right? And American Express and MasterCard, they were both storing data of Indian customers on US soil, right? And not just personal data, sensitive data, but also their transactional data, right? Because they were offering them, with credit cards and debit cards or whatnot. And so they had information of financial transactions of these users, right? And they wanted to, and the government of India wanted them to, store this data somewhere in India. And obviously these companies, they did not have an infrastructure ready and a policy ready to store data outside US, right? So government of India came and told them, that, listen, you cannot issue any new cards until and unless you start storing that data in India, right? So then these companies worked. It took them some time. I had a few friends working in Amex at that particular point, and then I think around October or November of 2022 was when they complied with all the regulatory and legal compliance orders issued by the government, and they were now allowed to operate in India. Then they were issuing new cards from that time onwards. So that is why Azure has global reach. Why? Because some countries may impose, let's say, some sort of uh, regulation or a policy on the organizations which are operating in that country, that they cannot store data outside, they cannot create resources outside, right? So in that case, Azure has to be there to cater to the need, right? So if Azure is not present in India, how would these companies who are now directed by the government of India to store data in India itself, where will they store the data? They have to either build their own data centers, right? Or they may have to use cloud services from other cloud service providers like Azure, AWS or GCP, right? So that is losing your market, right? So that is why Azure, Google, and AWS, they will create these data centers around the globe. The reasons are very simple: latency and legal compliance. So with that, guys, we'll stop the session here, right? All right. So tomorrow again, guys, we have a demo class, and tomorrow we'll complete these benefits, and then we'll uh, talk on a different topic, right? Apart from Azure basics and fundamentals, I want to discuss, let's say, Spark or Data Factory with you. So tomorrow we'll have another demo class where we'll talk about Spark, we'll talk about Data Factory, and we'll continue with the rest. All right. So thank you everyone for joining in
When
today.
these videos can be uploaded, like available for our
All right. So tomorrow again, guys, we have a demo class. So please do join. And again, thank you for being a part today. I hope to see you guys tomorrow again. Thank you, everyone.